I'm going to introduce a type of math that I didn't learn until university. But I wish that I learned it in high school because it's easy, it's fun, it's good exercise, and it's useful. It's called Boolean logic, and it's the math of statements and their truth. Over here I have a couple of statements here, and we're going to determine whether these statements are true or false. 5 is greater than 3. Is 5 greater than 3? Yes. So this statement is true. 1 is equal to 2. 1 is not equal to 2, so this is false. Water is H2O. Yes, water, H2O is the chemical name for water, so this is true. The color of this text is blue. The color of this text is actually golden yellow, so this is false. Now we're going to see what happens when we start combining these statements together and putting conjunctions in between them. For example, 5 is greater than 3, conjunction and 1 is equal to 2. Okay, let's see if this is true or false. Well, 5 is greater than 3, but 1 is not equal to 2. So, it's wrong to say that 5 is greater than 3 and 1 is equal to 2. This is false. Another example, water is H2O, or the color of this text is blue. Okay, well, water is H2O, so we don't really need to worry about the next part of this. So this is true. The color of this text is not blue. Well, yes, we just added this not here, so it's true. Because not negates the truth and falseness of a statement. There's a little bit more of a complicated one that I'm not going to get into right now, but I'm going to show you it because we're going to do the math and figure this out. If 1 is equal to 2, then water is not H2O. Okay, so if 1 is equal to 2, well, if you're reading this in English, then you're probably going to stop right there because 1 is not equal to 2. So what happens later doesn't really matter. And water is H2O, even if you wanted to delve into the statement further. But mathematicians want to assign a value to this. So I will explain that later. But first we need to introduce some symbols. And what do I mean by symbols? Well, mathematicians love symbols because they make things more generalized and they make things a lot simpler and easier to work with. Remember in grade school you do problems like these where there are 2 oranges in a bowl. If you add 3 more oranges to the bowl, you get 5 in total. It's a bit of a mouthful. And at first glance you think, okay, well, this works with oranges, but what about apples? It does work with apples. It works with anything. So we just simplify them into symbols. 2 plus 3 equals 5. Much easier to say. Now this number 2, number 3, number 5, these are called operands, and as you know, this plus symbol here is an operator. In Boolean logic, we also have operands and operators. The operands are just true and false. And the operators, I'm going to read these out to you, and I want you to become comfortable with them. We have not, and, or, implies, and if and only if. Over here, on the next page, I'm just going to show you how these statements work. Okay, so the not operator. All we need to say is that not true equals false, and not false equals true. Pretty natural, right? Now for the AND operator, I'm just going to introduce a table of values, kind of like the multiplication tables that you saw in grade school. But instead of multiplication, you see this AND symbol here, and it's going to show you what happens to true and false when you apply it to this. So we're reading this as P and Q, where this is the first column is P and the first row is Q. So true and true, okay, true statement and a true statement, that makes a true statement. A true statement and a false statement is false. A false statement and a true statement is false. And two false statements, false. So it's only true when both P and Q are true. It's false otherwise. And what about or? P or Q. Okay. So true or false is true. False or true is true. False or false, say, let's just go back to these. So 1 is equal to 2, or the color of this text is blue. Well, they're both false, so it would be wrong to say that 1 is equal to 2, or the color of this text is blue, so it's false. And if you're used to the normal usage of or, whether it's like either or, you can either have this or that, you might think that the or is exclusive. So true or true is false. But this or in math is actually inclusive. So true or true is true. If we preface this by saying either, then it would be different. But we have a different symbol for that I will show. Now, earlier you saw that if-then statement. And this is what it means. This is P implies Q. If P, then Q. So we define implies as if P is true, then Q must be true for the whole statement to be true. But if P is true and Q is false, then P does not imply Q, so it's false. But if P is false, then the statement is what we call vacuously true. So we just say that it's true. Okay, so true implies true. This is true. Now notice the order here, it didn't really matter for the previous ones, but it's going to matter for this one. True implies false. It's false. False implies true is true, and false implies false is true. Okay? The value of P if and only if Q is true whenever P and Q are both true or both false. But if one is true and one is false, then it's false. So in this case, true if and only if true is true. True if and only if false is false. False if and only if true is false. But false if and only if false is true. So this is how if and only if works. Okay, those are the basics of Boolean logic.